You want to use multiple AI models locally, but whenever you try to load them at the same time, your GPU explodes, or at least it takes them forever to do their jobs, and that's a problem. Well, in this video, I'll show you how I solve this issue. But if you don't know me, hello, my name is Maël Simon, and I'm an AI software engineer. So when you try to load multiple models locally, you are confronted with these problems. You don't have enough VRAM, which code the computer to load a model, do a little bit of tasks, and then unload it to load the next one, etc. in loop, so it takes forever. So to solve that, you could reduce the size of all the models so they all fit into your memory at once. But then the quality of your answer is reduced, and I've paid for my VRAM. I want to use it to its full potential. So to solve this issue, you could load a model into memory, generate with it, and then unload it, etc., etc. But the problem with that is that it takes time to load a model. So loading a model each time you want to make a generation is going to take a lot of time. But you can orchestrate all your models like the director of an orchestra, so that your models don't conflict with each other and optimize the loading time. And so I present you my inference request manager. So here are all our requirements. We want to load each model as if it is the only one. We want each model to respond as fast as usual, and we want to optimize the loading time. Usually what we do is we call the program to make the generation, we wait, we get the response, etc. But doing this way doesn't solve our issue. That's why I'm going to introduce the request concept. So each time you want to generate something, it could be a text, image, etc. You are not going to call the generation right away, you are going to make a request. The request is then going to be passed into a queue more on that later, and wait there. Once it's turned to be run, then it calls the generation, we wait for the generation to be processed, and then we get the response. Why process like this? Because you know the type of request you want to do and even the model that you want to call. We can put our request into the right queue, and then we'll have a loop that runs forever. The loop will take a queue, take the first request in it, process it, so it's going to send it to the different clients depending on the model. So for example, here it's Qwen 3, I'm going to use Ollama to process it. It processes it, and then we resort that, and the program can continue. After that, we take the second element in the queue, process it, answer, etc., etc. Once one queue is done, we process to the next one in the priority order, and we do the same, etc., etc. Once all the queues are empty, we can start again with a new cycle, and during this time, we may have other request inference that went into the queue, so we loop like that forever. The only problem with that solution is if you start to process, let's say, the queue for Qwen 332p, and that you add requests of this type faster than you can process them. In this situation, you're going to process the queue forever and you will never get on the other queues. And now that you have understood the concept, I'm going to show you how to implement this in Python. And I'm going to start with the inference request. So an inference request will have a model, which is the string, the model that I'm going to use to make the request, and a future. We use a future so like that when the request is processed, we can just fulfill the future and the rest of the code can await on that easily and simply. That's why we have a setup fulfill function, which only role is to test the result of the future. And we got an abstract method, which is the process. So each inference process will have a different process function. And I'm going to illustrate that with the text-to-text request. So in our text-to-text request, we've got specifics for our kind of request and a process function. This one, all it does is that it calls the function which is responsible to generate the stuff, get the result, and fulfill the future. That's all the process. And I'm going to show you what these functions look like. So because I make all my text-to-text inference with Ollama, I've got an Ollama client. This highly depends on what you're going to use. So you could use, for example, LM Studio or any other. You'll have to consult the documentation on how to do that. But for Ollama, here's how I did it. First thing, you need the URL where you're going to make the inference. And then you need to increase the timeout. Why? It's because with the default timeout, you're going to run out of time before the generation is made. And then here is the function. You create your payload. You make your request with HTTPX, get your response, and return it with a JSON. So it's really, really simple, just the basic. And so this response is going to be set inside the future, and the future will be completed so the rest of the code can continue. But how does it look? Here is the inference request manager. For me, this code runs inside a fast API server, so here is the implementation. You need to create the queues. I'm going to show you later how to do that. And all the magic lies into this. You have a process queues forever, which run inside a create task of AsyncQ. This allows the code to run the forever loop in the background. And then all you have to do is to create the inference object and put it in the queues. I've got an endpoint that allows me to generate some text. That's my entry point into the code. The only thing it does is it's going to call the generate text function. And then in our function, we create the inference request. We put it into the queue, and then here we await for the future to be completed. Like that, when the result of the future is set, we can return it directly and it's going to return it to our entry point. And here is the last part of our code, the inference queues. So what I've done is I set different kind of generation, and for each kind of generation, I have a set of different modules that can do this kind of generation. For the moment, I have only one kind of module for each kind of generation, but it may evolve later. Then we initialize the queues for each model. So each model is going to have one queue. And then we define a priority order. And after that, we send an event, but I'm going to get back on that later. We then have an add request function, which append a request to the corresponding queue. And again, the request event. And then we have the process all queues once. So like we said before, it's going to take all the queues in the priority order and empty them one at a time. And after that, the process queues forever, which basically will loop on the process all queues once. So what we've done is that we set a request event and we're going to wait. When we add a request to our queues, we're going to set the request event, and it's going to unlock this line. So we're going to process all the queues once, and then we check that all our queues are empty. If all our queues are empty, then we're going to clear the request event, and like that, it's going to pause and await there until we have another request. It's a really small but good optimization. And lastly, we've got this, the await AsyncQ sleep. Why do we have that? Well, if we don't have this sleep inside the while loop, then the while loop never gives the control back, which causes issue. So we have this sleep so that our system works as expected. So now you've seen how to generate text with Ollama. But what about images? Well, I spent over 20 hours to figure out the correct way to generate images without the web UI. And in this video, I'll show you how to do that.